Hello students, Marsh here. So today we're going to look at using properties of roots and exponents. You're going to want that graphic organizer we made in class, pen or a pencil, and then also possibly a calculator to do some simple math today. So let's remember, what were the properties of exponents? So the properties of exponents, remember, were if you were multiplying something with the same base, same thing with the same number on the bottom or same letter, you added your exponent. So this would be 3 plus 5, I would get x to the 8th, right? If I had a power to a power, you multiplied your exponents. So this would be 3 times 5, so I'd get x to the 15th. If you had stuff inside of exponents, you gave, or side of parentheses, excuse me, you gave that exponent to everything inside. So this would be a to the 5th times b to the 5th. If you had the same base being divided by each other, you subtracted your exponent. So it would be 4 minus 2. So that would be a to the 2nd. And then this one, you distribute that 3 in. So I get a to the 3rd over b to the 3rd. And then if you had a negative exponent, remember you flipped it and put it on the bottom of a fraction, and then your exponent became positive. So now you're going to want to grab out that foldable we made together, and you're going to want to open your tab to right here, simplifying exponents. And you're going to want to separate this into 6 different areas, okay? So make some lines here, boom, 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 boom. So you have 6 different areas. And how are we going to simplify powers? Well, we're going to use rules of exponents. So the first kind, you're going to add the exponents. So this should go in the first little box of your thing. It should go right here. So it should be number 1 right here, okay? So we're going to add exponents. Now, it doesn't matter that they're fractions. Basically, you're going to do the same thing. We're going to go 2 to the 3 halves plus 5 fourths. Now, remember, to add fractions, you do need to have a common denominator. So I'm going to get common denominator of 4. So to be 6 fourths plus 5 fourths, right? 'Cause 6 fourths and 3 halves are equivalent. Now let's add. I have 2 to the 6 plus 5, which is 11, and 4 plus 4. Oh, don't add your denominators. Jeez, Marsh. So it'd be 2 to the 11 fourths for my final answer for number 1. Number 2, you're going to multiply the exponents. So if I have something that looks like I have a power to a power, so same thing as if we had 4 to the 2nd to the 3rd, we're now going to multiply the fractions. So it's going to be 4 to the 2/6 times 3 fourths. So let's multiply my exponents together. So I'm going to get 4 to the 2 times 3, which is 6. And 6 times 4, which is 24. Now 6 times 20, or 6 over 24, I think that simplifies, doesn't it? What can come out of 6 and 24? A 6, right? So I can make this 4 to the 1/4 instead. What about this one? What are we going to do? Well, there's stuff inside of the parentheses, right? So we're going to give the exponent or the power to all. So we're going to make sure that 3 gets distributed in. Remember, it's not the distributed property though. If we're using it as distribute out something, give it out. So let's multiply. So it'd be 5 to the 1/3 times 3. And then 7 to the 1/4 times 3. Let's multiply that out. 1/3 times 3, well, that's 3 over 3, which is just 1, so that would just be 5, right? And then 1/4 times 3 would be 3 fourths. Now, we can't multiply this, right? Because they're not the same base. So you're going to leave them as is. It's going to be 5 times 7 to the 3 fourths. What about if I have the same base and I'm dividing? Well, you're going to subtract the powers, right? So I'm going to get 8, and it's going to be 9/7 minus 1/2. Okay? Need a common denominator for those two, I think. Let's use 14. So it'd be 8 to the 14. 7 times 2 would give me 14. So 9 times 2 is 18. And then 7 times 2 gave me 14. So 7 times 1 is 7. So let's subtract here. 18 minus 7 is 11. Keep my denominator. So my final answer is 8 and the 11/14 power. What about this kind? When I have x over 27 to the 1/3 power. So what we're going to want to do, give the power to the entire fraction inside the parentheses. So we're going to have x to the 1/3 and 27 to the 1/3. So x to the 1/3, 27 to the 1/3. 27 to the 1/3 power. Let's check our perfect roots chart quick. Go on my cube roots column. 27's on there. Let's go over to the left. What is the cube root of 27? 3. So I have x to the 1/3 all over 3. If you can simplify a number, if I give you something with a number, please make sure you simplify that. That way it becomes nicer, looks a little cleaner. What if I have something like this? You're going to need to move the base with the negative power up to the top or down to the bottom, depending on where it is. Well, in this case, I have this guy. He's in the bottom, so we're going to move him to the top. So now I'm going to have 4 to the 7/2 times 4 to the 3/2. Now, same base, right? So we go back to having to add our exponents. So I'm going to have 4 to the 7/2 plus 3/2. Add it, same denominator. So it'd be 4 to the 10/2, right? 7 plus 3 is 10. Keep the denominator. That'd be 4 to the 5th. Well, you're not going to leave it as 4 to the 5th. What's 4 to the 5th? So let's look on our perfect roots chart here. Under the 5th power column, in the 4, let's follow our fingers. Looks like 4 to the 5th is the same as 1,024, right? Couple more examples just to watch to make sure you're aware. If I have these again for subtracting, gonna want to subtract here, right? So that'd be 4 to the 7/2 minus 3/2, which is the same as 4 to the 4/2, right? Because 7 minus 3. 4/2 is the same as 2. Don't forget to simplify your exponents. And then 4 to the 2nd, well, that's 16. So look at the difference here. This is the same as 16. It's just written really funky. You're going to want to simplify as far as you can go. What about this one? So I have 3 over 3 to the 1/4. Well, they're the same base, right? This has a 1 here, right? It's 3 to the 1st. So I can subtract my exponents. So 1 minus 1/4. Now, don't think too hard on that. Think of it as $1, and you're going to take away a quarter. Don't you have 3/4 left? So it'd be 3 3/4 for my final answer, right? Yeah. And that's the end of this video. See you later, Sabers.